So write down what is friction. Write down friction means. Write down friction is an electromagnetic force. Electromagnetic force applied by electromagnetic force means due to charge. Okay, charge particles applied by electrons, and this force is developed due to roughness or irregularities. Clear?
Okay, bro.
So what happened, like, for example, this is any block, and if this block is placed on a floor, this is the floor, okay? This
Okay.
is the floor. On this block is placed. This block is having the mass m, and if you look at from your naked eye, this is from your naked eye you can't see. This is the surface in contact. If I zoom this surface, it looks plain. Clear? If you look at the bottom of the surface of this block and the floor, it looks like shiny. There is no irregularities you can see with the help of naked eye. But if you look at from the electron microscope, there, then on this contact surface, there is some irregularities like this. There, this is the irregularities of the like this. This is the irregularities on this contact surface of the floor. If you look at the bottom of this block, bottom surface of this block, it is also having some irregularities, and there is some interlocking between the irregularities of this surface like this. Clear? This is the irregularity of this block and irregularities of the floor. They got locked, like interlocking happened like this. So this interlocking happened because of this. This block is not easily moved. Clear?
Okay.
Clear? So friction is an electromagnetic force that is applied by the electron, and this force is developed due to roughness or irregularity. When you place any object on any other object, then because of deformities or roughness or irregularities, the block is not easily moved on the surface because of this friction. You just tell me, this is block. Here, this is floor. This is the, my fingers are the irregularities on the floor. This is the irregularities on the block. When this block is placed on the floor, there is interlocking. There is interlocking between the irregularities of the block and the floor, like this. Now, if you apply the force, then will this allow? Tell me, will this interlocking allow you? No. Clear?
Like resistor.
Clear?
Yes, sir.
Now, if you apply force on this block, then you need to break this interlocking. Clear? If you break this interlocking, then again interlocking happen. Clear? Clear work? So, if you apply the force on this block, then we need to break this interlocking, then only you can easily move this block. Understood?
Sir, then how it is an electromagnetic force, sir?
Electromagnetic force means when you place on the surface, the atoms of your like bottom of the block and the floor, they are in contact. They are electronic repulsion. I will tell the electron of the block and the electron of the like this floor. There is a repulsion between the electrons. Because of this, there is a one contact force that I will draw here. Clear like this.
Sir, but they are neutral forces only now, sir.
What?
But the atoms are neutral only now, sir. In both the block and the floor, the atoms are very neutral.
They are neutral, but see, this is block. Clear? This is floor. When they are coming contact like this, when they are in contact, when they are very, very close, then there is a repulsion between the electrons. Clear? The electron, because surface is not smooth, like surface is not perfect, we can say circle. Clear? It has different deformities like this. So because of this, there is one resultant contact force, FC. Clear? Resultant contact force. The component of this in vertical direction is normal, and the component of this in horizontal direction is friction force on this block, like this. So there is resultant contact force. It is not perfectly 90 degree. The surface is smooth. Then this FC will be perfect 90. Clear? There is no friction. Clear? So,
sir, what is that FC, sir?
what is FC? FC is, you can write resultant contact force. Resultant contact force. The component of this,
sir, what is
in y direction, is normal reaction force. Normal reaction force. And this parallel component is parallel to the surface. See, this friction force is parallel to the contact. So if I draw here also, because of this repulsion, this is my system. Clear? This is my system. Because of repulsion between the electrons, or we can say because of electromagnetic force, there is one resultant contact force. This FC will be like this. Maybe. Clear? And the component of this in y direction, the component of this, you will draw x and y like this now. X and y. The component of this in y direction will be normal. And component parallel to the contact surface. Parallel to the contact surface or parallel to the surface is known as friction. Clear?
okay?
Frictional force. So frictional force is a type of contact force that is acting parallel or tangentially to the contact surface. If this surface is in contact, then friction will be like this. Clear? Friction will be like this. So friction, we say now, friction is a type of
resultant contact force.
What?
What is that resultant contact force? What is the meaning, sir?
Contact force means simply the block is placed on the floor. Clear? When the blocks are very, very close, it will compress this. Clear? It will sit, it will interlock. Clear? Then the atoms are very, very that much close. Atoms are that much close. So they will apply the force on each other. Here there is repulsion. The electrons of the floor will apply the repulsion force on the electrons of the block. But it should not be 90 degree to the surface, because there is a deformities, there is a irregularities. So it will be at certain angle like this. So angle, clear? So component of this resultant contact force, as FC, is normal. And one component that is parallel to the contact surface is known as friction. Clear? So
Yes.
this you will learn in depth electromagnetic force in class 12. So I just explain, otherwise in every book they will explain like this: friction is a force that is parallel to the contact surface, it opposes the motion. But I will tell friction is a type of contact force because it is a component of FC. Clear? That is parallel to the contact surface. Clear? Is it clear to you?
Sure, yes, sir.
Okay. So this, I think this is clear to you. Now write down, if you wish, like I will say what is the direction of friction also. This is the floor. On this floor, if you kept one block, then friction, it may be in the right, it may be in the left. I will tell. This FC can be like this also. Clear? This FC can be like this. Depends on situation. FC is a resultant contact force. The component of FC in y direction, this is normal. If you take this is theta, then it will be FC cos theta, and this is friction. Clear? This is, you can say, FC sin theta, but we never write FC sin theta. We are writing directly friction. This is friction. Clear? So friction is not a new force, it is a component of FC. Clear?
Okay, sir.
Now you just tell me, so direction I'm telling, like for example, this block is placed on this block like this. So this is the surface in contact. This is the surface in contact. If I draw here, so friction will be parallel to this like this. This is the direction of friction. It is always tangentially to the surface. There you can write also direction of friction. Direction of friction is tangentially to the surface in contact. Surfaces contact. Clear?
Okay, sir.
Doubt? Now, moving to the types of friction, right on the heading. Types of write down. First, static friction. Static friction. Write down. It is a friction. Then write. It is a friction. This color is visible to you.
Yes, sir.
It is a friction. I think I should use dark little. You can write. It is a
Sir,
friction.
it is visible, sir.
Visible. It is a friction which acts between two surfaces. It is a friction which acts between two surfaces which are relatively which are relatively rest. Which are relatively rest. You can write also velocity. Rest means velocity and acceleration of both bodies should be same in magnitude, should be same in magnitude and direction. Clear? So it is a friction which acts between two surfaces which are relatively rest. Clear? They should not move. Velocity and
Okay,
acceleration
sir.
must be equal. First write, then I will explain. Okay. Write down magnitude of static friction magnitude of static friction magnitude of static friction is self adjusting between 0 and USN. Okay. So value of friction will lie static friction. Fs means static friction lies between 0 to mu SN. What is N? N is the normal reaction. Okay. What is mu S? You can write. I will explain. Don't worry. Okay. Mu S is
Okay.
coefficient of static friction. What is N? Normal in surfaces where friction is considered. Okay.
Yes, sir.
This mu SN, this mu SN, you can write this is the limiting friction. Limiting. So meaning is what? For example, if I kept one block on the floor like this, clear? There are two objects. One object is this block, one is floor. Clear?
Yes, sir.
Meaning is that if you take heavy box displaced on the floor, now you please tell me relatively rest मतलब क्या होता है? What relatively rest means? You tell me what is the velocity of block with respect to floor? Zero.
Yes,
Velocity
sir.
of floor with respect to block? Zero. Both are relatively at rest. Clear?
Yes, sir.
Clear? Now, if you apply no force, if you are not applying any force, then see It is a friction which acts between two surfaces which are relatively rest. Condition is which are relatively rest. If it is not relatively rest, this friction will not be there. Clear?
Okay.
Next is direction. Direction of this friction. First write this. Write this one important point. Direction of this friction is in such a way. Which friction? Static friction. You can write direction of static friction in such a way that it opposes the tendency of motion. Tendency of meaning is what? For example, this is the floor on which I kept the block like this. Clear? I kept this block, and if you are not applying any force, clear? Then there is no friction. Fs is 0. Clear? Because there is no tendency of motion. Clear? Friction, this friction, static friction always opposes the tendency of motion. If you are not applying any force, there is no tendency of motion in this block. Clear? But let us suppose you are applying a force on this block. If you apply a certain force, this is force applied. Let us suppose you apply 2 Newton. Clear? You apply 2 Newton. Then if you apply the force on this block, in which direction? In which direction? Tell me. Right. Then this block has a tendency of motion in which direction? Right. Clear?
Okay, sure.
Then if you apply
Yes,
the
sir.
force 2 Newton in the right, then this block has a tendency of motion in the right. Then friction always opposes the tendency of motion. Then friction will be in the left. This is the direction of static friction. And since this static friction is self-adjusting, so its value will be 2 Newton. Self-adjusting means it adjusts its value according to the applied force. There. But if you apply, let us
Okay.
suppose you are applying, now you are applying 3 Newton. You are applying 3 Newton on this. Clear? Then friction will be, static friction becomes 3 Newton. Like this. If you apply, let us suppose 4 Newton, static friction become 4 Newton. Now you please tell me, in all these cases, here object is at rest, still it is at rest, relatively rest. Clear? Here it is relatively rest. Here also relatively rest. Because 2 minus 2, there is no acceleration. Here also relatively rest. Same here. Still it is in relatively rest condition. Clear? Clock will not move.
Okay, sir.
Clear? But let us suppose friction minimum value is 0, static friction minimum value is 0, and its maximum value is mu s n. Clear? This mu s n value, maximum value of static friction is, let us suppose 4 Newton. 4 Newton. This is known as, what I will tell, this maximum value is 4 Newton. Clear? Because friction can adjust, the static friction can adjust its value up to a certain limit. Clear? So it can adjust its value up to a maximum value. So its maximum value is 4 Newton. Still, if you apply a force, let us suppose you are applying a force on this block. if you apply, let us suppose 5 Newton, then what will happen? Static friction maximum it can apply how much? 4 Newton, na? Clear?
Yes, sir.
Then
Then the object will move 1 Newton.
the object will be in motion. Static friction will not be there. Clear? Static
Sir,
friction
then
will
that
not
4
be there.
Newton,
See,
sir, that 4 Newton is called the coefficient, sir.
you can say like 4 Newton, but my question is, you are absolutely right. When you are applying 5 Newton, then up to 4 it can stop. But 5 Newton is more than 4 Newton. Then this block will be in motion. There is no static friction. Remember, there is no static friction because condition of static friction is relatively rest. Clear? Relatively rest.
Okay.
Here, relatively rest. This is
No,
the
sir.
maximum value of static friction. This is known as limiting friction. What? Limiting friction. Clear?
Sir, then that 4 Newton is both that coefficient and limiting friction, sir.
What?
That 4 Newton is both that limiting friction and coefficient of friction, sir.
Coefficient of friction different thing. Okay. This FL, this FM, I'm denoting limiting friction by mu s maximum value of this mu SL. Clear? This FL is 4
Okay.
Newton. This mu s is different thing. Okay, I will tell. Clear? Limiting friction.
Okay,
FL
sir.
is limiting friction. Its maximum value of static friction is limiting friction. Its value is 4 Newton. Once this block, the condition is relatively rest. Clear? Relatively rest. Then only static friction will be there. You can check. The value of static friction lies between, you can write also, it lies between 0 to its maximum value, that is mu s. Okay. This is known as limiting friction. FL.
Okay, sir.
Mu s is different thing, okay? Mu s is coefficient of static friction. What is mu s? Coefficient of
Coefficient of static friction.
static. Clear? Is this
Yes, sir.
clear? Is this clear to any
Yes,
doubt?
sir.
Any doubt?
Sir, the value of coefficient of static friction is what, sir?
The value of coefficient of friction like mu 0.1, 0.2, like this. They will give.
Okay, sir.
Okay. Now,
Okay, sir.
after this, you can write also. This is like a general knowledge thing. I will write. You can write during walking. They can ask you direct question. Okay.
Okay, sir.
You can write this. GK type question. Good. Right. Okay. During walking, you are walking on the road now. During walking,
Okay.
friction is static. During walking, friction is static and act in forward direction. Because of this, you are able to clear friction help us to move on the ground. Clear?
Okay, sir.
Because when you are moving your foot back, so the tendency of motion is left, going back, and friction is moving you front. Clear?
Okay, sir.
Now after this, write down. Next is sliding friction. Type sliding friction has many types. First is kinetic friction. Kinetic friction. Next is rolling friction. Rolling friction. Sliding friction means simply motion. An object is in motion. Yeah. Any doubt?
No, sir.
So you can write also. Write down. Write down. Sliding friction, about sliding friction, write down. Sliding friction, one more friction like kinetic friction. Directly. Kinetic friction. Clear?
Okay, sir.
Write down. It is a friction. Write down. It is a friction which acts between the surfaces which are in relative motion. Okay? Motion. Which means relative motion means bracket you can write velocity or acceleration velocity or acceleration of both bodies are different. Yeah. Either in magnitude or direction. Either in magnitude and direction. Yeah.
Okay, sir.
Now sliding friction magnitude is you can write magnitude of magnetic friction is a type of sliding friction. Okay, you can write magnitude of either I can say kinetic friction or sliding friction. Clear? Just understand.
Okay, sir.
Magnitude of kinetic friction is fixed. It is not self-adjusting. Okay, and
Oh,
it is equal to then right X pointer is not here. So kinetic friction is K. So Fk is what? Kinetic here.
okay.
So you can write also what is mu K? Coefficient of
Coefficient of kinetic
kinetic
friction.
coefficient of kinetic. See, clear? This mu k,
Yes.
you can write important note. Important note. Write down k. K is slightly less than mu s. Clear? Any doubt?
No, sir.
लिख लिया आप लोग? Have you written?
Yes, sir.
Okay. Now draw. Now we will draw the graph. This graph is very important. Okay. I'm drawing on y-axis. I'm taking friction. Okay. On x-axis, I'm taking force applied.
Okay, sir.
Force applied means what? See, this is a block on which I'm applying force applied. Clear? Now, if you look at carefully, if you apply a force, then this block is at relatively rest. Clear? Then what will happen?
Okay, sir.
If you increase the applied force, static friction also increase. Here, friction increase up to a maximum value. Clear? This is the maximum value of what? Limiting static friction, that is FL. Clear?
Okay, sir.
If you apply more than that, if you applied a force more than that, then block start moving. This is like this. This is known as FK, kinetic friction. Clear? Clear, Dinesh?
Okay, sir.
It
Yes,
is just
sir.
like it is just straight. Okay, straight. From here to here, to attain maximum value from here to here will be static. Static friction. From here, sliding is kinetic.
Okay, sir.
And it is constant. Okay. Here, like
Okay.
if you ask me, this is constant. This is a graph. Here, you can check also this here. This FK is less than FL. FK is kinetic friction is UK into N plus. So mu k is less than. Clear?
Okay, sir.
You can write also direction how to find the direction of say it will attain. See friction. If you applied force increase, then friction value increase. Then it will attain its peak value. Then sudden drop. When object is in motion, sudden drop because kinetic friction start acting. Now object is in
Okay,
motion.
sir.
There is no static friction. Clear? Write one point
Okay,
direction of what is the direction of kinetic friction? You can write direction of direction of kinetic friction kinetic friction is such that it opposes the opposes the relative motion. Clear? Hello. Meaning is that. Meaning is what? For example, this is one vehicle. This vehicle is moving with 5 meter per second square on the right. Clear? There
Okay,
is
sir.
one block on this vehicle and it is moving with 3 meter per second square. So first you understand velocity. Okay, 5 meter per second, 3 meter per second. You can say this is block A or block B, vehicle A, vehicle B. Now if you look at this carefully, if I ask you what is the relative velocity of A with respect to B? VA minus VB down, down. Clear? Velocity of A as
Okay.
seen from the ground is 5. Velocity of B is 3. No, what is the velocity? 2 meter per second. So according to B, A is moving with a 2 meter per second the right. Plus means right. Clear? So what is the direction of kinetic friction? On A due to B, it opposes the relative motion. The relative motion of block A is in the right. So friction acting on this will be left. Clear?
Okay, sir.
Similarly, if you solve what is the relative velocity of B with respect to A, you will write VB minus VA. So VB positive because it is going in the right. Clear? 3
Yes,
A
sir.
is going on the right. It will be minus 2 meter per second. So minus means this B is going back. Relative motion is in the backward direction. Clear? According to A, B is going back. Its tendency of motion, not tendency, its relative motion is in the backward direction. So A will oppose it. A will apply the friction force where? The right. Clear?
Okay, sir.
So friction, the direction of kinetic friction is such that opposes the relative motion. The relative motion of A is in the right direction, plus 2. Plus means right. That's why friction is in the left, on A, on A. Clear? Similarly, on B, friction will be in the right because its relative motion is in the back, minus 2 meters. Clear? Okay.
Sir, can you please repeat it again?
I'm again. It's very little bit tough. Again, I'm repeating. Okay. No need to worry.
Okay, sir.
This is block A. This is block B.
Okay, sir.
It is going in the right 5 meter per second. Clear? It is going in the right 3 meter per second. If you take B as a system, this is your system. Okay. Now,
Okay, sir.
I want to draw the free body diagram. It's weight of B, normal, and one friction will be there. I don't know what is the direction of friction. Which friction? Kinetic. Clear?
Okay, sir.
Now you please tell me my system is B. Clear? So B is my system and you are the observer. You are on the A. Not A. You are on the A. Clear? So what is the velocity of B with respect to you? A. VB minus VA. Clear?
Okay, sir.
The ground. So B is going in the right 3. A is going in the right from the ground minus 5. You please tell me what is the velocity of B? Minus 2 meter per second.
Okay, sir.
And if you look at from the A, if you are the observer standing on the A and look at B, then B is going back minus 2 meter per second. Clear?
Okay, sir.
Minus 2 means B is going back 2 meter per second. Now you please tell me what is the relative motion of B? Back or right? Backward or rightward direction?
So relative motion of B is backwards, sir.
Backward. So friction opposes the relative motion. Then A will apply the
Then
friction. Clear? Because we will not be include in free body diagram surrounding how much force they are going to apply by the surrounding, not by the system itself. So A will apply the friction on B will be in the right, like this.
okay, sir.
Clear? Now again I will draw same diagram. I will draw again like this. Say this is B. Okay. Now
Okay, sir.
our system is sorry. Now our system is A. Clear?
Okay, sir.
System is A. Now B is the your observer. You are standing on the clear. Now you are looking A. So what is the velocity of A with respect to you means B. A 5 minus 3 2.
2 meter per second.
Clear?
Rightward direction. Okay, sir.
Rightward direction means what is the direction of what is the relative motion of A? Right or left?
Right, sir.
Very good. So friction will be left.
Left.
Clear? Normal will be
Okay,
on
sir.
this due to B, due to floor. Floor it is on the floor now. Due to B is not clear.
Okay, sir.
But F and F, this is actually this is not static. Okay, this is kinetic. This is kinetic. Okay, I just write F. Kinetic friction value is F, small f. Clear?
Oh, okay, sir.
Now one question I will give you if you can solve this. Okay. You need to find the direction of static friction on both the blocks.
Okay, sir.
This is A, this is B. Here, and this is moving with 6 meter per second, and it is going with 2 meter per second. Tell me. Solve this. One question is this.
Sir, 1 minute, sir. I will solve this.
So this is first question. You need to find the direction of. First, you check whether they have relative motion or not. If they have relative motion, there is a kinetic friction. You need to tell me the kinetic friction. Here,
Sir,
action
it
for
is in
everyone.
relative motion, sir.
Yeah, very good. Now there is a kinetic friction. See, I am talking about this surface in contact. This surface in
Okay, sir.
contact, now friction will be here only. So for first consider B as a system, draw the friction force. Then consider A as a system, draw the friction force. Draw.
Sir, for friction in the body B, the friction acts in the left direction, sir.
Body A.
Finding, sir. 1 minute, sir.
Yeah.
Sir, for A body, it is in right direction.
Okay, we'll check. What is the velocity of for velocity of B with respect to A? 6 minus 4. Velocity of A with respect to B, A minus A. A is 2 minus 6, that is minus 4. So velocity of B with respect to A is in the right. Then friction will be left. On A, one is left, then one is right. Clear?
Okay, sir.
Next question solves. One block. One more block is going in the left with 3. Is going in the. You can't say like they have no relative velocity. See, velocity is had direction. They have different direction. Even magnitude is same, clear, but they have different velocity because direction
Okay,
is opposite.
different.
Solve.
1 minute, sir. I will solve. Sir, for body B, friction lacked in right direction, sir.
For body B,
Friction lacked in right direction.
for BVA, BB minus 3 minus 6 means left. So according to A, B is going back. Action will be velocity of A.
Friction lacked in the backward direction for body A.
Body and solid. Body. This is for B. This
Okay.
is for B. Yeah.
Okay.
So I am writing like this. Okay. Clear. VAB. Velocity of A with respect to B. VA minus VB. VA is going right. Minus 3. 6 plus 6 matlab velocity of A as seen by the B. B is looking A and A is going in the right. Right means friction on A will be left. This is not clear.
Okay, sir.
Clear. Now after this,
Yes, sir.
write down factors. What are the factors? Write down. I think this is clear to you. Write down the factors affecting frictional coefficient. I am how much? This class is frictional write down first frictional coefficient you understand? US, UK,
Yes. Yes,
write
sir.
down it depends on it depends on type of material of both bodies contact. Clear? Depends on type of material. If you take different material in contact, then this value is different. For
Okay, sir.
glass and copper, different friction. For glass and glycerin, different friction. So it depends on type of material that are in contact. Okay? See, Let us suppose this is the surface. There, on this surface, you place a block. Here, Dinesh.
Yes, sir.
And I already told this is the resultant contact force, FC. This is X, Y, okay?
Okay.
X or Y. This is, let us suppose, theta. There, the component of this will be FC cos theta. And one component in the, like this, FC sin theta. Clear?
Yes, sir.
Then this is what? FC cos theta, this is normal. We are learning normal now from a long time. Actually, this is component of contact force. Clear? This is normal.
Okay.
This is
Okay.
FC sin theta, na? This is friction actually. FC sin theta. Now you just tell me if FC is more inclined. Please tell me. When theta is more. When FC is like this. Here, theta is more. When sin theta is more, then friction will be clear. Where FC is
Okay.
very, when theta is 90 degrees, then friction is maximum. Clear? When contact force. Okay. And in that condition, cos 90 is 0 and normal is 0. Clear?
Yes, sir.
This you can write also friction F is equal to what? Sorry. F is equal to FC sin theta. The maximum value of this friction force is U and there UN. Know this? You know this? I think you are aware or not. I think right first. Okay. This mu into
Okay.
n is less than equal to FC sin theta. Clear? And this n is what? FC cos theta. So mu will be less than equal to tan theta. Clear? Why am I writing this? You know? Is it clear?
Sir. Yes, sir.
I think you are familiar or not. This mu
No,
into
sir.
n is what? It is a what? It is
Sir,
what?
uh, tan theta into cos theta.
See, FC, sorry, mu into n is the limiting friction, maximum value.
Yes, sir.
Either it should be less than that, clear, or it should be equal to this. Maximum it can be
Okay.
FC sin theta, clear, or you can say a value of static friction because this is the condition we are applying when object is at relatively rest. Clear?
Yes, sir.
So for relatively rest, this is the condition. Mu must be at least mu should be minimum value of mu will be maximum value of mu will be tan theta. Clear? This theta is what? Angle of friction. What? Angle of okay.
Okay, sir.
You know the value of friction lies between 0 to mu n. So
Yes, sir.
clear? If mu n is mu n can be less than that there or it may be equal to this. Clear? Actually
Okay,
mu
sir.
n is also the static friction value. Clear? Now, when you are applying when you are applying, what is happening? When you are applying, uh, uh, when you are applying applied force on this, yeah, when you are applying applied force, then FC, this FC, now this FC is adjusting this theta. Clear? This FC is adjusting this theta in such a way this block should not move. Clear? This block should not. You please tell me when I'm saying like this static friction, when this value is 2 Newton, let us suppose, then it will FC will be at certain angle in such a way this FC sin theta also 2 Newton. This total value. Clear?
Okay, sir.
This FC sin theta 2 Newton. Again you are increasing the force. Again it is changing this theta. It is again increasing. Again it is increasing. So it can increase up to a maximum value. Clear?
Yes, sir.
So mu s and this maximum can be, it will be maximum what? Maximum value is u into clear. Static friction maximum value is u into n. This is limiting friction. What? Limiting friction. Okay. So
Okay.
if any question like they are asking if inclination is given, let us suppose theta is clear to you. What is theta? Like this, if block is placed on the floor like this, and they have given a contact force of 2 Newton, and this block is having the mass 2 kg, this theta is 45 degree. You can directly find this mu. It will be tan theta, tan 40. This clear?
Okay, sir.
This theta is 45 is angle of friction. Is it clear?
Yes, sir.
So you can write value of mu. You can write
Value of
important note. You can write important note. Mu can exceed the value of 1, and practically we have achieved we have achieved maximum value of 1.6. Maximum we have achieved till 1.6. Value of mu maximum. How much? 1.6.
1 point.
Experimentally, okay.
Okay, sir.
Next write down this coefficient of friction. Write down. It does not depends on does not depend on area of contact. Okay. Third point write down. Friction is different. Okay. Friction depends friction depends on velocity. Where friction depends on
Okay.
velocity according to variable function. This is theoretical thing, okay?
Okay.
See, in solid friction is there, in liquid friction is there, okay? In gases friction is there. So for low speed of solid, friction is power of 0. Experimentally, okay, v to the power 0. For high speed of liquid, friction vary high speed of liquid.
Sir, what is V for 0, sir?
The velocity of solid, okay. V to the power 0
So
means
V
it
for
is
0 will be 1 only, no, sir?
power 0 means it is very negligible, okay. Low speed now,
Okay.
so v to the power 0. Constant almost, there is no change. For high speed of
So V
liquid,
to
it
the
is v to
power.
the power 1. More the velocity, more is the friction. For
Okay.
very high speed, I'm comparing, okay. In solid friction is v to the power up to 0. For high speed of liquid, it is v to the power 1. Clear? For very high speed of gases, you can write very high speed of gases friction depends on velocity na, then how it vary? V to the power 2. Meaning is what? If the velocity is 2 meter per second, then if solid is moving 2 meter per second, if liquid is moving 2 meter per second, if gas is moving 2 meter per second, then in which case friction is more? Gases.
Gas.
In check. For for solid, to the power 0.
1.
For liquid, 2 to the power 1. For 2 to the power 2. Over here 2, here 1. So in which case more friction? Gases.
Gas.
Okay? Meaning is that.
Okay.
Yeah. So they mainly like friction depends on velocity. So according to variable function, if speed is low or solid, so you can use this relation. F is directly proportional to v to the power 0. This there is no change in friction. Similarly, for low speed of solid, for high speed of liquid, liquids are moving very high speed. Their friction is directly proportional to the v to the power 1, power 1. So if they can give you direct value of v, you can find. For very high speed of gases, v to the power 2. Okay, like the when a rocket is going into the atmosphere, missile is going to the atmosphere, lot of very high speed gases are coming back. Their friction will be v to the power 2. It's very high friction.
Okay.
Clear? Okay,
Okay.
so you can write next point, last point. Slide finish.
Sir, one doubt, sir.
Yes.
Sir, if friction is equal to V square, then the object will not move, no, sir.
If friction is
Proportional to V square, then the object will not move, no, sir.
no. Friction means simply like what are you saying?
Sir, here for gases, F is proportional to V square, sir.
Okay.
If friction is 2 times greater than the velocity, then how it will move, sir?
See, gases in our atmosphere, when any object is coming towards our planet Earth, there is a blanket of atmosphere, gases. Clear? If it is coming with
Okay.
any velocity, then heavy friction is going to act on its body. Because of this, it's burn. Clear?
Okay, sir.
So why it burn? Because even if you are moving with 100 km per hour, or then friction is square. Meaning is that if you are coming to our planet Earth with a certain velocity, with very high
Sir,
velocity,
but in here friction is a force and velocity is meter per second, no, sir. The SI unit changes, no, sir.
it's a
How
relation
can it?
simply like qualitative relation. Like direct formula I didn't give you. Simply I'm telling if any object is coming to our atmosphere at a very high speed, clear, then the entire gas molecule disturb. Their speed becomes high. Because of this, the entire body burn. Clear?
Okay, sir. Yes, sir.
You can imagine also when any like a meteor, no, any comet, any stone, if you throw in our atmosphere from the space, then the stone burn. Clear? Because lot
Yes,
of drag, heavy drag. Clear?
yes, sir.
Liquid, liquid when you are taking a liquid in a like centrifugal machine. Centrifugal machine like mixer. If you take a liquid
Yes,
in a
sir.
mixer, if you rotate it is very high, then liquid is also moving very high. Then if you touch the metallic part, it is burning. It is little bit hot. You observe this because of friction. Clear?
Okay, sir. Yes,
So
sir.
one point actually I want to tell, like maybe today also, I think today only I will finish this topic. Tomorrow I think maybe next week. Okay.
Okay, sir.
Right, last point. It is experimentally, okay? It is experimental things I'm telling.
Okay,
Very
sir.
well. How friction vary? They can ask with the velocity, with the high speed of liquid. How friction vary? They can ask e to the power 1. With high speed, very high speed of gas, how friction vary? More the speed of gas, friction will be more. More the speed of liquid, more is the friction. More friction it will generate. Clear? If the solid speed is
Okay.
very low, then friction is independent means very less. E to the power 0 means very less. There is less friction in solid if its speed is low. If the speed of liquid is high, then friction is what? E to the power 1 means little
Okay.
bit high. If
Okay, sir.
for very high speed of gases, friction is directly proportional to the V square. If gases are moving very fast, very high speed, clear, then there is more friction. Did you observe that when you are moving with your bike or a car or a bicycle and wind is coming from the opposite side, clear, then what will happen? You are not easily moved, clear.
Yes, sir.
For example, you are running your bicycle this direction, and wind is coming. Wind is what? Gases, molecule, gases. Clear? Gases.
Okay.
Gases. So if the speed of gas is very high, then it will create more friction on it. Clear?
Okay, sir.
Clear?
Yes, sir. Yes, sir.
I will stop here because I have next class. One last point I will discuss tomorrow. Okay. Just
Okay,
revise
sir.
this again. We'll discuss tomorrow. Thank you so much.
Thank you, sir. Bye, sir.